Can you distinguish plastic and polymer? Plastic and polymer are same or different? So what is the differentiation between plastic, polymer, elastomer and fibers? These all are not same. They have their own properties. So this can be explained in this video. The topic is classification of polymers. Based on different points, polymers can be classified into many types. So in that first one is polymers can be classified into two types based on their occurrence source, how the polymers are obtained to us. So we can classify into two types. One is natural polymers. The polymers obtained from natural materials are called natural polymers. So for example, if you see the cotton produces the natural polymer. Silk, from the silkworms, wood is a natural polymer used to make a papers. And latex is obtained from the trees like Avia brasiliensis and Gutta percha trees. Latex having a isoprene units, we can produce the polyisoprenes, that is called natural rubber. This can be used for the different applications. And crustacean shells having chitin. Chitin is the most important polymer which is using in the biomedical polymers. So like that, proteins from the eggs having also natural polymers. These all are available from the natural sources. That's why these are called natural polymers. So second one is synthetic polymers. The polymers which is produced from the laboratories. That means man-made polymers are all called synthetic polymers. Example: polyvinyl chloride, polyethylene, polystyrene, nylon, bakelite. These are the synthetic polymers. And if you observe the table, different natural and synthetic polymers: proteins, air, skin, tissues; polysaccharides, cellulose, starch; polynucleosides, DNA, RNA. These are all the natural polymers. Some of the polymers also within our human body. So our body also made by different types of polymers. So synthetic polymers: nylon, polystyrene, acrylics, polyvinyls, polystyrenes. So daily life we are using different types of synthetic polymers. So this is the classification based on their occurrence. Second one is based on the type of monomers. So we all know different number of monomers combined each other by the covalent bonds and forms a large molecule. That large molecule is called polymer. So repeating units present in the polymer is called monomers. So by the nature of type of monomer, we can differentiate the polymers in two types. First one is homopolymer, second one is heteropolymer. Homopolymer means if only one type of monomer repeating throughout the polymer, then that polymer is called homopolymer. If you observe here, so A is the repeating unit, A connected with the another A, like that. If you throughout the polymer chain only one type of A monomer only repeating here, that's why it is called homopolymer. For example, polyvinyl chloride, polystyrene, polyethylene. If you observe here, polyethylene having only ethylene molecule repeating and forms a polyethylene molecule. And next one is heteropolymer. It is also called copolymer. Here not only one monomer, more than one monomer present in the polymer chain. That means repeating unit is not same. If you observe here, A connected with B, B connected with A connected with B. So there is a two types of monomers is there, A and B. So if a polymer chain having more than one monomer, more than one type of monomer, then it is called heteropolymer or copolymer. For example, bakelite having phenol and formaldehyde, buna S having butadiene and styrene, buna N having butadiene and acrylonitrile. That means two monomers present in the these all the examples. These are called the copolymer or heteropolymers. This is the classification based on type of monomers present in the polymer. So next one, you can see here the examples. If the monomers are A and B, so there is a two types of monomers is A and B. If only A is involved in the polymerization, it is called homopolymer. A and B both are involved in polymerization, forms a polymer, is called heteropolymer. Examples are examples. So you can see here the ethylene molecule, they form a, so number of monomers form a CCC. So only this only repeating here, you can observe here only ethylene molecule only repeating here. This is a homopolymer. If you observe this butadiene S rubber, this is the styrene molecule and this is the butadiene, both are combined which forms a poly polymer, that is called Buena S rubber. Here two types of monomers is there. That's why it is called heteropolymer. Okay. Next, in copolymers, the copolymer means more than one monomer present in the polymer chain. The arrangement of the different monomers present in the copolymer, they can be classified into three types. Okay. So observe the in this slide, if you see here, you can observe here one heteropolymer is there, here one heteropolymer is there, and here one heteropolymer. These three are example for heteropolymers or copolymers. Why? Because in the three examples, the polymer chain having more than one monomer, it is sure, right? But the arrangement of monomers are different. If you observe the first one, after A, B came, B after A, alternatively A and B arranged each other. This is called alternating copolymer. If you observe the second one, there is no order, randomly they are arranged each other. That's why it is called random copolymer. In third one, they arranged alternatively but as a blocks. If you see, first three A monomers came, then B monomers, then C, then A, then B, then C. That one order is there. So orderly blockwise they are arranged alternative. That's why it is called block copolymer. So this is the arrangement based on the monomeric units in copolymer. So these are all copolymers, but the monomers arrangements are different. So we can classify into three types: alternative, random, block copolymers. Okay, so you can see an example here. So this is the homopolymer. So why? Because the only one monomer is there throughout the chain, that's why it is a homopolymer, no doubts. So these three are the copolymers. These three are example for copolymers. But here if you observe red blue alternatively come, that's why it is called alternative copolymer. If you see a red next to three blues, next to two reds, there is no order, that's why it is a random copolymer. If you observe the first one chain is came, one type of monomer is connected with another type of monomer, blockwise it came, that's why it is called block copolymer. Based on the polymer chain structure, polymers can be classified into different ways. So for example, first one is linear polymers. That means the polymers having only straight chains or linear chains, then that is called linear polymers. Example, polyvinyl chloride. If you observe the polyvinyl chloride, so polymers having only linear chains, so polyethylene, so they having only linear chains, that is called linear polymers. And some polymers having branches, so those are called branched polymers. If you observe here, so actually there is no connection here, so you can not consider that example. If you there is a polymer, so one side chain is there, another branches is there, like this branches is there, so then the type of polymer is called branched polymer. And third one is cross-linked or network polymers, or three-dimensional polymers. That means a linear polymer chain, another linear polymer chain connected with covalent bonds. Then the type of polymers is called cross-linked polymers. If you observe here, so this is the one type of polymer chain, linear polymer chain. This is another linear polymer chain. Both are connected with the another chain. There is a cross-linked bonds between the two polymer chains. That's why it is called cross-linked polymers. Because of these structures, their properties also will change. I will explain in the later slides this how they are influence the properties of the polymers. So you can observe here polyethylene. Polyethylene having a linear polymer chain. Polyethylene having a linear polymer chain. You can observe here it's a straight chain. So this is only one chain. It is a straight chain, linear chain. So if you observe the branched polymers here, one linear chain is there, but some branches is there on the linear chain. This is the branches. This is the branches. So this is the example for the branched polymer. So this is the example for the three-dimensional cross-linked bond. This is the one linear chain. This is the another linear chain. The two linear chains are connected with the covalent bonds. So this type of cross-linked bonds is called three-dimensional cross-linked structure. So based on the synthesis method, polymers can be classified into two types: additional polymerization and condensed polymerized products. Additional polymerization means the monomers combine each other and forms a large molecule. In this process, only pure addition between monomers takes place. The monomers which having double or triple bond involved in the additional polymerization. So here double bond will break and they forms a new bond with the another molecule. That's mean there is only arrangement of bonds. There is no net loss of atoms. Every atom in the reactant will be retained in the product. That type of polymers is called additional polymerized products. For example, polystyrene, polyethylene, polyvinyl chloride, who having double or triple bond, they involved in the additional polymerization. Condensation polymerization mean here also monomers combined each other. That means here also addition is there, but along with addition there is a elimination of small molecules like H2O, H2S, NH3, HCl will takes place. That means addition followed by elimination is called condensation polymerization. So in both process addition is same, but in addition polymerization, pure addition, there is no elimination. In condensation polymerization, addition followed by elimination. For example, nylon 60T, polyester, bakelite, these all are having the functional groups like COOH, OH, NH2, COCl, like this, who having the functional groups, they involved in the condensation polymerization process. So you can see the mechanism of the polymerization here. So for example, ethene molecule having double bond, this ethene molecule interact with the another ethyl molecule by making this bond. This bond will involve in the arrangements. This bond will come between the two monomers. So double bond will break down here and new single bond is formed. Like that the process continues. This type of polymers is called additional polymerization. If you observe, if you count the monomers, we count the number of atoms in monomers. So one, two, four hydrogens, two carbons. If you see here, four hydrogens and two carbons retained in the final product. So this type of polymerization products is called additional polymerization. The condition for additional polymerization is a monomer must have double or triple bond. Next one is condensation polymerization. If you see here, it's a diacid. A monomer should have two functional group. So this monomer having two functional group. One is COH one side, another COH one side. Another monomer is diamine. This monomer having also two functional group NH2 and NH2. Now this COH group and NH2 involved in the condensation process, and they loses the water molecule and forms a amide bond, C double bond ONH. This is the amide bond. Both are combined each other, but they lose the water molecule. This type of polymerization is called condensed polymerization process. So like that, this addition between the acids and alcohols forms the esters. So C double bond O ester is formed. Polyesters will form, but there is a loss of water molecule is there. So like that, small molecules will lose during the additional process. Then that process is called condensed polymerization process. So next one is the differences between additional polymerization and condensed polymerization process. Addition means just joining each other, simple addition. Condensation means addition followed by elimination. In additional polymerization there is no elimination, but condensed polymerization elimination of small units like NH2 and NH3, sorry, H2O and NH3. So it is a chain mechanism. It is a stepwise mechanism. So that means one monomer contact with the another one, like that its chain is going on. So that is called additional polymerization here. So monomers forms dimer forms tetramers forms octamers forms decamer. Like that, stepwise chain will increases, stepwise polymer growth increases. That's why it is called condensed polymerization. So it is a additional polymer is a rapid polymerization. So initiators generally it's a very fast. You cannot control the polymerization process. It's required initiators. But condensation polymerization is comparatively slow polymerization process with additional polymerization. And in this process, catalysts are required to start the reaction. And example for the additional polymerization is polyvinyl chloride, polyethylene, polystyrene. So example for the condensation formation is bakelite, nylon, polyester. So who having double or triple bond involved in the additional formation, who having functional groups on the monomer involved in the condensation formation process. So final one, based on the intermolecular forces between the polymer chains. Polymers can be classified into four types. Those are thermoplastics, thermosetting, elastomers, and fibers. Okay, so it's purely based on the intermolecular forces between the polymer chains. One chain and another chain, how they are attractive, how they are repulsive, how they are densified. So based on their structure, based on their molecular forces between the polymer chains, so they can be classified into thermosetting and thermoplastic. First of all, we discuss what are the differences between thermoplastics and thermosetting. Thermoplastic mean the polymers which become soft on heating, and which become hard on cooling is called thermoplastic polymers. That means you can make it soft many times by heating process. That means you can reshape the molecule many times. For example, one of the plastic object made by the thermoplastics. So when you are using it is destroyed, you can heat it and make it soft, and you can make another object. What you desired shape, you can make another desired shape. That type of plastics are called thermoplastics. But the plastic which doesn't become soft on eating, is called thermosetting plastics. If you heat more and more, they involve in combustion, but they are not become soft. Those are called thermosetting plastics. So these thermoplastic maximum prepared by the additional polymerization, thermosetting polymers prepared by the condensation polymerization. Addition mean only addition, condensation mean addition followed by elimination. Okay, so generally thermoplastic having a straight chains. So if you observe here, there is a straight chain polymers is there, so these are the straight chain polymers. There is no cross link between the chains. Okay, if you observe the thermosetting polymers, there is a cross link between the polymer chains. That means, so there is a strong covalent bonds between the polymer chains. It is a chemical bond is there. Here only physical attractions between the polymer chains is there in the thermoplastics. In thermoplastics, the interaction between the one chain and another chain by weak van der Waals forces. But in thermosettings, there is a strong covalent bond is there. So obviously, so cross-linked thermosetting polymers are thermally stable compared to the thermoplastics. So that's why thermoplastics are weak van der Waals forces. They are soft, weak, and less brittle. They held by weak van der Waals forces. They dissolve in organic solvents. So they have low melting points. If you observe the cross-linked thermosetting polymers, they have three-dimensional cross-linked bonds. They having the strong covalent bonds. They held by strong covalent bonds. They are insoluble in organic solvents. They doesn't soluble in organic solvents, and they having higher melting points. Okay, but the thing is, these are become soft on heating. That's why thermoplastics can be recycled, remodeled, reshaped, and reused, but thermosetting cannot be recycled. They cannot be remolded, reshaped, or reused. These are the differences between the thermoplastic and thermosettings. An example for thermoplastics is polyethylene, polyvinyl chloride, polystyrene, and nylon. An example for thermosetting plastics is phenol formaldehyde resin, urea formaldehyde resin, nylon, sorry, polyamides. These are the example for the thermosetting polymers. Okay, so this is a very important one when you are studying the classification of polymers. So next type is elastomers. Elastomers means the polymers which can be stretched at least 3 to 10 times than their original length. These are called extendable polymers, is called elastomers or rubbers. Example, Buna S and Buna N. In this, there is a coil-like structure. It's the heavy polymers, rigid and tough. They can be stretchable more than 3 times than their original shape. Those are called elastomers. Final classification is fibers. Fibers are thread forming solids which having high tensile strength. They are like metals like structure. They are malleable. They having a strong intermolecular forces. So those are strong hydrogen bonding. If you observe the here hydrogen bonding between the two polymer chains, so this can make the they give the highest strength for the polymer. So these are called fibers. They can used in the thread forming solid materials. So fibers, cable wires, optical wires, bulletproof jackets, they are using in their applications in different fields. So these are the classification, overall classification based on different parameters. Okay, so thank you for listening.